All right, so this video builds off of the video from the previous in this series. So there should be a 69, a regular 69. So if you haven't watched that, please pause this video, go back and watch that other one first so that you can follow along a little bit better. So I want to talk a little bit about division of functions. So we talked about adding and subtracting and some of the notation for that. So you can do the same thing with division. If I'm going to give you f and I'm going to give you g, and I say, hey, f divided by g, where the x value is the input, well, really this is saying, hey, we're taking the f, x minus 7, and then you're going to divide it by the g, which is 2x squared minus 13x minus 7. And I hope that you start to see that this is really kind of the same thing we did in the rational function topic, where you got the x minus 7 on the top, and you can really factor this denominator. So I'm going to go ahead and do that. So two numbers that multiply to negative 14 that add up to negative 13. Well, that is, 1 times negative 14. So we've got 2x squared. So I'm just factoring here. I've got x and negative 14x. So we've got 2x and then 7, negative 7, and that becomes 1. So our factored form is 2x plus 1 and x minus 7. Well, you'll start to notice here that the numerator and the denominator, they have this fancy version of 1. And so be really careful here because this is a 1. So we're left with 1 on the numerator and 2x plus 1 on the denominator. And so, gosh, don't want that to go out. So I'll just share the division. If I were to divide these two problems, we would get our final answer of 1 divided by 2x plus 1. So this shouldn't feel too much different than the rational function unit that we had been doing earlier in this quarter. All right, I want to do one more with you just so that we get a little bit of practice. If you want to pause the video, it's a good idea to practice just a little bit before you get started. So do f over g, or f divided by g of x. And really what this is saying, and I'll give you, this is really saying, hey, we're taking f of x, I should have explained this in the previous slide, f of x divided by g of x, right? If it was g over f, it would be flipped around, but here it is. So pause the video, try it out, and then unpause when you're ready to see. So hopefully at this point you've gotten a chance to practice this on your own. So we'll first rewrite this problem. So f is x squared minus 3x minus 18 over g, which is x plus 3. And we want to factor the numerator. So the factored version of the numerator over x plus 3. So that ends up being x plus 6. X minus 6 times x plus 3. That's really handy because this is a fancy version of 1, right? It becomes 1, so this ends up being x minus 6, and that's our final answer. So when you divide f divided by g, you get x minus 6, which is a lot easier to deal with. All right, so we're going to do a little bit more about composition functions, and we've studied them a little bit in the previous video, but they can be kind of confusing and a little bit challenging at first. So remember we talked a little bit about the notation f, that little zero-looking thing, it's a little circle, really means the composition. So we're composing f in, g is going to go into f. Another way of writing what this says is f of g of x. So g is going inside of the f function. So we'll start with, and I like to use the word stuff because I think it feels a little bit less intimidating. If I'm going to start with f, we can see is the square root of x plus 7, or the square root of stuff plus 7, where the stuff is the thing inside the parentheses. So the square root of stuff plus 7. And what is that stuff? That stuff happens to be g of x. So g of x is 2x minus 5. So we've essentially replaced the x with g. We've replaced the x with g. So in the equation, the x gets replaced with the thing that we called g. And then we got to simplify. So we don't want to forget to simplify that plus 7 is inside the parentheses. So this ends up being the square root of 2x plus 2, because negative 5 plus 7 is 2. So f of g of x is this more simplified, it's a rule essentially, function, f of g of x. We'll do a few more because I recognize that some of this can take some time to build up understanding. All right, so it doesn't have to go both ways, and I've rewritten these a couple of different ways. So we've got a new function f, we've got a new function g, and so we're going to do f of g of x, and another way to write that is f composed with g, with the input of x. And then we're going to do it kind of backwards. We're going to say g of f of x, where f of x goes into the function g. And another way to write that is g composed with f with the input of x. So we'll do this first side first. I'll pause, and I'll have you try the second way just to get practice with this concept. So I'm going to try and colorize it as best I can. In this case, f is blue, so f of x. But what is the g stuff? The g stuff is 4 minus x. So every time in the f function, when I see an x, and when I see an input, a previous x value, we're going to replace it with x. So one way to think about that is in the f function, every time I have an x, I think about this function as stuff squared plus stuff plus 2. So when I think about it that way, stuff squared plus stuff plus 2. Well, what stuff squared plus stuff plus 2? Well, what is that stuff? That stuff is this x minus 4. Excuse me, this 4 minus x. So 4 minus x. 4 minus x. I keep writing it wrong. 4 minus x. And as we go through, we're going to have to continue to use some of those ideas of what does it mean? What does this exponent of 2 mean? Well, this means 4 minus x times 4 minus x. And then we can combine like terms here because it's just addition. So 4 plus 2, that ends up being 6, and then a negative x. So 4 times 4 is 16. We've got negative 4x, another negative 4x, and then negative x times negative x is positive x squared. And then we still have this 6 plus 6 and this negative x. So we'll just combine like terms. So negative 4, negative 8, and negative 9. So negative 9x. We've got an x squared here, so an x squared, negative 9x, and combine the like terms. So we've got 16 plus 6, so plus 22. So go ahead and pause the video, take a moment. I'm going to try and go step by step in the second one, but it's helpful to try these out and then see a solution. And I want you to think about it. You're taking the function f and you're putting it into the function g. So if you think of g as 4 minus stuff, what are you going to put in that place for the stuff? All right, so I'm going to go and I'm going to help you set it up. So g of f of x. So 4 minus stuff, but the stuff is f. The stuff is f. The stuff is x squared plus x plus 2. And this becomes kind of this nice subtraction problem where you're going to have to distribute that negative sign. So 4 minus x squared minus x minus 2. And this one was a lot easier than the previous one. So 4 take away 2. So we get negative x squared minus x plus 2. And so this ends up being our answer for g of f of x. We're going to do one more, and then hopefully you'll be able to practice a little bit more over the next few days. I don't expect you to master this right now, but it is a good starting point. So you go ahead and try these. I will magically make the answers appear, so please pause the video so that you get a chance to try these out. So I took g and I substituted g into f. So f of stuff being x minus 5, stuff squared plus 1, that's f. F is x squared plus 1, so in my equation I wrote x minus 5, quantity squared, plus 1, and simplified down. Go ahead and, if you haven't done the second one, go ahead and do that really quickly, and then I'll make it magically appear on the page. All right, I hope this video was supportive for you. Please bring questions to class tomorrow and make sure that you finish the homework for tonight. Thanks so much for watching, and I'll see you in the next video.